In this case, we are going to look at f of x equal to 2 to the minus x. Again, if a is greater than 1, remember we rewrote that fraction as a to the minus x. So my first one is my green graph again, which I can use as my mother graph. It's a decreasing function, and I have a domain of R and a range of 0 to infinity. I do not have any x-intercept, but my y-intercept will be at 2 to the minus 0, which is 2 to the plus 0, which is equal to 1. Remember, plus 0 and minus 1 is exactly the same. Then my horizontal asymptote again is the x-axis, or y equal to 0. Horizontal is always y equals something. Vertical asymptote is always x equal to something. So let us look at the blue graph. It is not surprising that the domain and the range is exactly the same as we had before, and we have no x-intercept, and the y-intercept will now be 3 to the minus 0, which is also 1, and no vertical asymptote, and my horizontal asymptote y equal to 0, that is my x-axis. Good, so now I want to look again at the graphs, and now you will see that the 3 to the minus x on the left hand side, the y values of the blue graph is larger than the green graph. Then it's exactly the same at x equal to 0, and then they swap. Then the 2 to the minus x is greater than 3 to the minus x when x is positive. I see I've typed here 4 to the plus x, but it should be 4 to the minus x. Again, the domain is equal to R, the range is equal to from 0 to infinity, no x-intercept, and the reason why I include x-intercept every time is when we shift these functions, then it will sometimes have x-intercept. So don't forget to include it, and don't just assume that it doesn't have an intercept, because we will get to some of them that will have an x-intercept as well as a y-intercept. The y-intercept that happens at x equal to 0, and that will be 4 to the minus 0, which is equal to 1. No vertical asymptote, and my horizontal asymptote is again y equal to 0 or the x-axis. So the green graph here is y equal to 2 to the minus x, the blue graph y equal to 3 to the minus x, the red graph is y equal to 4 to the minus x, and the purple graph is y equal to 10 to the minus x. If I first look at the properties of p of x equal to 10 to the minus x, I get the domain is R again. The range is again from 0 to infinity. I do not have an x-intercept. I have a y-intercept of 10 to the minus 0, which is equal to 1. I do not have a vertical asymptote, but I have a horizontal asymptote y equal to 0 or the x-axis. If we look at x less than 0, then the smaller the a is, 2, 3, 4, 10, the smaller the graph, the y value of that graph is on the left hand side for x negative. Because when we put in 2 to the minus 1, I will get 2, and 3 to the minus 1, I will get 3, and 4 to the minus 1, I will get 4, and 10 to the minus 1, I will get 10. They all intercept here at x equal to 0 with a y value of 1, and if I look at d of the value at d, then I get 2 to the minus 1, which is a half, 3 to the minus 1, which is equal to a third, 4 to the minus 1, which is equal to a quarter, and 10 to the minus 1, which is equal to 1 over 10. And you can see that that is larger than that, is larger than that. So a half is larger than a third, is larger than a quarter, is larger than a tenth, and that's why it's like that on the right hand side. I like to always look at the values at -1, 0 and +1 to see where I position my graphs. Because sometimes you're unsure whether it's on top or below, but if you just check those three values, you know the shape. So you just check that three values and then you can draw your graphs. In this table is just a summary of what I just said. At x equals 0, they will all cut there at the same y value. When x is less than 0, then the larger the a value is, the higher the graph will go. And when x is less than 0, then the larger the a value is, the lower the graph will go. Or just calculate the values at -1, 0 and +1 and then make the dots and draw the graphs according to that, relatively to the mother graph. In this case I've used 2 to the x as a mother graph.